You've got 50 million vectors from your AI embeddings. You can't just dump them into a Python list and call it a day. You need persistence, filtering, and speed. That's where vector databases come in. Every vector database, no matter the brand, has the same core components. An API layer for REST or gRPC, a query engine with vector search and metadata filtering, a storage engine, and an index like HNSW. Think of it as layers working together. The data model is simple but powerful. Every record has an ID, a vector, that's your 768 or 1536 floats, and a payload with metadata like title, author, date, and category. You search by vector for meaning and filter by payload for precision. Let's start with written in Rust, built for production. It's fast, memory efficient with built-in quantization and has excellent filtering. The killer feature. Payload filtering happens at the HNSW level, not after retrieval. That distinction matters a lot. Is fully managed, you don't run anything. Zero ops, automatic scaling, and a paper query option. Great if you don't want to manage infrastructure. But watch out for vendor lock-in and costs at scale. Is GraphQL native with a module ecosystem? It has built-in vectorization, just plug in your embedding model. The GraphQL API is powerful for complex data models, but it can be overkill for simple use cases, and Java memory overhead is real. Chroma is the of vector databases. Dead simple API, it embeds text for you, runs in process with no server needed. Perfect for prototyping. But don't expect it to handle production scale, it's single machine only. And then there's vectors inside your existing. No new infrastructure needed. You get full SQL power, ACID transactions, and joins with other tables. The trade-off: it's slower than purpose-built vector databases. When you insert a vector, the database doesn't just append it to a file. It validates dimensions, stores the vector data in memory-mapped files or RAM, stores the metadata in a key-value store, and then adds it to the HNSW graph by finding the right layer and connecting to nearest neighbors. Most vector databases use segments like LSM trees in RocksDB. New vectors go into a mutable segment optimized for writes. Periodically, segments merge and compact into immutable segments optimized for reads. Write fast now, read fast later. Now here's the hardest problem: metadata filtering. Say you want vectors similar to X where category equals tech and date is after 2024. Sounds simple, right? It's actually brutal. There are two naive approaches, and both have problems. Pre-filtering filters first, then searches the remaining set. But if only 100 vectors match your filter out of 10 million, HNSW can't work efficiently, you're brute forcing. Post-filtering searches first, then filters results. But you asked for top 10 and only 3 pass the filter. Wasteful. This hybrid approach solves this elegantly. During HNSW navigation, each candidate node is checked against the metadata filter. If it passes, it's a potential result. If not, skip it but still use it for navigation. You get exact top K filtered results fast, so which one should you pick? Here's the cheat sheet. Prototype or hackathon, Chroma, already using SQL, production with self-hosting, no ops team and need managed. Complex data models with GraphQL, my recommendation. Start with Chroma to learn fast, then graduate to when you're ready for production. It's open source, self, and handles filtered search like a champ. Next episode, chunking strategies. How you split your documents changes everything about retrieval quality.